So we're gonna do away with this y equals thing. Okay, we're not gonna really do that anymore. Okay, so and that's kind of functions as functions, and like we're gonna introduce this like kind of important thing. It's called function notation. So that's kind of like the learning goal. Can you like define it and kind of work with it, right? So here's what your equations typically look like, always, or have in your past math, right? Here's what function notation looks like, okay? Now the difference between the two is this y turns into this f of x thing. So the f is like a function of x, right? So it kind of gets into the this notion of there being like function machines, right? Where I can like input things and they're going to spit out outputs, right? So same thing. So basically, essentially what's happening, y turns into f of x for your equations. That's basically it, okay? That's the only thing that changes. And then it reads the value of f at x. So you want the value of the function when x equals this, right? So when I input a value of x, I want to know what the value of the function is, or y. That's how that reads. Does that make sense? So for this one, example A, I want to know what the function reads when I plug in x equals 6. Does that make sense? So all I have to do is, it's like everything we just did yesterday, but I'm only interested in the value when x equals 6, right? So I'm just going to go like this. Okay, well, 3 times 6 plus 1, right? That's 18 plus 1 should equal 19. We're good. Same as the solutions.
So you write it as f bracket 19?
Yeah, so it's like f, oh no, sorry. You'll say, so like kind of what's going on here is like instead of writing a table of values like x and y, which can get tedious and annoying, especially like I don't care about some of them, right? What's nice about function notation is you can go like this. F at 6 is equal to 19. That tells me when x equals 6, the y value is 19, right? And then like maybe I'm interested in f of 2, right? For whatever particular reason. What's the value of the function when x equals 2? Well, plug it in. It's going to be 3 times 2 is 6 plus 1 is 7. It's a little bit nicer than writing a table of values, I think, right? So then part B is just, okay, well, what's the value of f of x when x is negative 2, right? Okay, well, plug it in. Right? So we're going to get negative 6. Careful with your signs, as I am not. Right? So then maybe I would like to see, okay, well, f at negative 2 is equal to negative 5. If that's specifically asked for, that may be what I want to kind of see, right? Is everybody okay with that? Okay, so that's you saying, okay, well, I'm going to input things, and I'm going to get outputs. Same thing as yesterday, right? Same thing as a function machine. I'm going to input something, I'm going to get outputs, right? The other part here now, okay, is like this part here is, here's a function machine. It wants to find the value of x, is backwards, that gives me the function value of 22, right? So instead of inputting something this time, I now know the output, it's 22, and I want to find the input that makes it 22. Does that make sense? So you just go like this. Okay, well, f of x is equal to 22, right? I'm just taking the function here, right? So I'm going to go 22 is equal to 3x plus 1. Right, see that? So this is telling you, you can see it right here, this is almost like a substitution thing, right? There's f of x, it's equal to 22. I see f of x over here. So you're just replacing it with a number, right? Yeah, right? And then you just solve for x, right? So I can go 22, I'm going to subtract 1 from both sides, right? So minus 1 is equal to 3x. I can go like this now. Right? So I get 21 is equal to 3x. I can divide both sides by 3. X is equal to 7. There's the input, what I have to put into my machine in order to get an output of 22. Make sense? It's like X and Y, that's all it is. Just ask, it's just a different look. Okay? Do we have any questions so far? Okay. So that's one way to do it. You kind of do it algebraically, right? And then if we scroll down a little bit, when we look at this, it's asking you for a bunch of different information from the graph, right? And you'll notice I've highlighted 3 points on your graph, right? Or I colored them in a little more visible, right? There are these 3, right? So there's the function, okay? This one here wants to know what's the value of the function, right? So here's your function. If you're following this along, right? You're going, okay, boom, 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 boom. I'm going to follow the function, and I want to know what the value, how tall is it when x equals 3? That's what that's saying, right? So then I go find x equals 3, and I read up. Okay, well, there's the value, right? Did we see what I did? Go find x equals 3 and read up, right? So then you can say, okay, well, the value here is 1, 2, right? So when x equals 3 on the g function, I mean, the other thing about function notation is I can draw multiple functions or multiple graphs on the same axes and label them different things. So I could say f of x and g of x and like k of x. I could label them all different things, and I could ask you for g of 3 or k of 3, and I could go read off what the values are for any particular x, right? Whereas before you might have to, there's a lot more words going with the equations, right? Because they're actual equations, right? So we see how I did that one? And then let's go find, I'm going to do these in different colors so we can kind of see. So I want, what's the value of the graph when x equals -1, right? So I go find -1. What's the value? It's right on 0, right? So then I get to go like this, 0. Okay. And then this last one, much like this question. It told me what the output was. So where on the graph I am, and then it wants to know what value of x gives me that. That's what the last one's asking. So x, if the value of the function is 1. So then you're riding along the function and you go, okay, where am I going to hit 1? Right there. What x makes that work? 0. Right? So it happens at 0. Right? So therefore you can write g at 0 equals 1. Okay? Kind of a nice note. It keeps everything organized, right? We can kind of see what's going on. I know how to read that off, right? Whereas if that just said, oh, y equals x squared or something, right? You might not know if there was 2 of them on there. Well, which one am I finding the value for, right? It might be a little more confusing. Okay. Everybody okay? So the next part here, I don't know why this is like, I see kids struggle with this all the time. Absolutely nothing different going on here. Like absolutely 0, right? The only thing that's changed is we're plugging in something different for x. Still plugging something in, it just doesn't, it's not a number. It's a variable and a number now, right? So you physically get to go down here and do this. You're just replacing h at n plus 3 is equal to 2. Now I'm replacing the x with n plus 3. n plus 3 plus 6. right? And it wants to know, just like all you have to do is expand and collect like terms, right? So if I put the 2 in, right, I'm looking for the value where n plus 3, 2n plus 6 plus another 6. Is everybody okay with that step?
Why did you add the 6?
What? I haven't done, I'm not fully done yet. I still gotta, now I'm gonna collect the like terms, right? So now my final answer, I'll write the final answer and then we'll clear up anything. So this is what happens when I put in n plus 3 into this function, right? I get out something else. Is that okay? Is there any questions? Does that clear up the 6 plus 6 thing? Kind of, sort of. Okay, so let's go back then. So we'll is everybody okay with this notion here? If I take the n plus 3 and I replace it in the equation, that's all that's happened. So you can see how, like, I replaced the x with the n plus 3, right? So there's n plus 3, and there's where the x was, right? I just replaced it with n plus 3. And then I just did some distribution work, right? So the 2 has to get multiplied into the brackets, and everything that's in the inside of the brackets has to get multiplied by the 2, right? So then I got 2n, right? Plus 6, that came from the 2 times 3, and then I had the 6 back on at the end, and then I just collected the like terms. Right? And that's how I get my answer. Are we okay with that? Whatever this says to do, you just do it, right? You just put it in for x right here. Wherever you see the x, it just goes right in there. Doesn't matter what it is. It doesn't matter how complicated the function is. You just do it, right? And just run with the mathematics that we have to use. Okay. Okay. Why don't we take a little break here? We'll pause. Unless you want me to do these. These look very similar. Why don't we hit? You want me to do these ones? I'll do them. We'll just rip through them. Okay. Here's your x. I see x. I also see x here. You're going to replace it with 2 minus 5w, right? So I want the value of the function when x is equal to 2 minus 5w. So I get 5 minus 3 times. Okay. Distribute the negative 3 in. Does anybody have any major disputes? Okay. These turn into this. And then this one turned into this. And I still had the 5 out front, right? That's still floating down. So then you just collect the like terms that exist. That's these guys, right? That's going to be negative 1 plus 15w. Any major concerns? Okay. So remember, like, even if you're struggling right now, like, you can always go back and, like, you can watch them again, okay? But if you have a question, ask it, because then that might clear something up. Yeah?
When you take, like, the negative 3x and you move, and then, like, down here it's become 5 minus 3, and you got rid of the x entirely, is that just because the x has moved over into
the x got replaced with
by the domain, right?
this guy here,
Okay.
went in for
Right.
x.
Okay, that makes sense. I
Okay.
just wanted
Good.
clarification.
So again, I don't care what's in it's f at whatever. You're just going to take what's in the brackets, and it's going to go in where the x appears in the equation. That's all. Okay? Okay? Can we get rid of that? I can leave that sitting there. This one, very similar to the one we had earlier. We want to find the value of x that makes the equation equal to 23. Very similar. Yeah.
On like the last question of the other page, couldn't we like simplify more by dividing by 2?
Sure. Yeah. You want to do that? That's okay. So we can go like this. H n plus 3 is equal to, we can factor out to 2, right? That's where you're getting at. Okay. There we see what he did. So there's, I see that I could divide everything by 2 and pull it out, right? So then the 2 comes out front, and then you write whatever's left after you take the 2 out. So you'll see 2n divided by 2 is just n, and 12 divided by 2 is 6. Okay, that's good. Yeah. If it said, it did say simplify, so that's kind of my bad, right? Fully simplify. So factor it out. Okay. Can't do anything with this one though, I don't think. I think this one's good. Okay. And then, so this is like this question here. Like this one. Right? So I'm given what the output is from my function machine. It's 23, right? I want to find the x value, that the input that gives me 23, right? So h of x is equal to 23. So this turns into 23, h of x, because that's what it's telling me over here. And then it's equal to 4x plus 3. So then it's just a linear equation that you're going to solve now. Right? You're going to subtract 3 from both sides. Right? So I'm going to get 20 is equal to 4x. Divide both sides by 4. X is equal to 5. And then you could write a concluding statement that said h at 5 is equal to 23. Right? Okay. And then there's only one more. It's not a whole lot I can ask you with these things, right? I can throw one more wrench in it, aside from the next question, but that's about it. You just, the general principle is whatever it tells you to put in for x, just do it, and then do the math on it, and simplify. That's it, right? Doesn't matter if it's a number, it doesn't matter if it's an expression. You just take it, put it into the equation. Okay? Is everybody okay with that one? Okay? This last one's a little bit trickier, but kind of cool. Okay? So I've got two things going on here. We've got the skills that we've just built, right? This is kind of like where we're going to end up. Where I'm taking values of x and I'm putting them into the equation and getting numbers, right? But I got two different things going on here. I basically want to find the difference between the y values on the graph. It's almost like the change in the rise or something like that. Like almost like slope, but not really, because I don't have the run, right? So these are two y values. This could be like y2 minus y1. So I'm finding the difference, right? I'm finding the height difference between these 2 points. That's kind of what this is asking me, right? So all you have to do is just you do the same stuff we've just been doing, but in 2 steps. So the first step is I'm going to do h at 2, and I'm going to get a number, right? I'm going to go 4 times 2 plus 3. So that's 8 plus 3, right? Should be, okay? So h at 2 equals 11, right? And I'm going to do the same thing for the second one. I want to find the value of the function when x equals 1. So h at 1 is equal to 4 times 1 plus 3 should equal 4 plus 3 should equal 7, right? So that's h, right? And then the last step to this, you want to find the difference. h at 2 minus h at 1. You take the values. What did h at 2 equal? 11. And what did h at 1 equal? Alright, so just plug those in. Here's your answer. Done. Any questions? Okay, good stuff.